Hello dear students, we are going to start rearrangement reactions. So our first rearrangement is Beckmann rearrangement. Okay, in Beckmann rearrangement, first of all, what is Beckmann rearrangement? So Beckmann rearrangement is conversion of aldehyde or ketone into amide. Okay, how this takes place? The first step of the reaction is uh, reaction of hydroxylamine with ketone. So the lone pairs on the nitrogen of hydroxylamine attack the electrophilic center of carbon. The electrons involved in this pi bond formation transfer to the oxygen, and oxygen will get negative charge. Here you can see this. Okay, and after removal of water from here, OH minus OH, this OH and hydrogen from here. Okay, you can see here minus H2O. Okay, water molecules remove and here pi bond will form. These oxygen take proton from here, and the electrons involved in NH bond formation will form a bond over here. Okay, you can see this here. This species is called as oxime. This is oxime. Okay, these oxime on protonation undergo rearrangement reaction, undergo Beckmann rearrangement, be specific. So what is the source of proton? Here you can use any acid, HCl or H2SO4. Sometimes instead of acid we use catalyst like PCl5, SOCl2. Okay, that we will see in our next examples. Okay, so I have forgotten here to write acid. Keep it in mind that here is acid which convert this OH into the good living group. Okay, you can see here I have protonate the OH group, and that OH group will after converting into good living group, rearrangement will take place. What will happen in rearrangement? Group trans towards the living group migrated toward the nitrogen. Okay, you can see here the CH3 group here get migrated towards nitrogen in the next step. Okay, so what is happened here? Carbocation is formed. This carbocation get attacked by water molecule. Okay, you can see here O lone pairs on oxygen attacked here. Okay, this is attached to the carbocation, and because of that these electrons involved in, and after that deprotonation will take place here. As oxygen have positive charge, is try to neutralize that charge, and it form a pi bond over with carbon. Okay, and generate a carbonyl center. You can see in this here, and then the hydrogen which is attached to the oxygen get transferred to the nitrogen, and we get our amide. You can see here nitrogen has one hydrogen. From where it hydrogen comes? It comes from here, the which is hydrogen which is attached to our oxygen is get taken by nitrogen. Okay, so this is Beckmann rearrangement. It's a very simple reaction. How to remember this? The first step is attack of hydroxylamine and formation of our oxime. Okay, then protonation of that oxime, and because of protonation rearrangement takes place. In rearrangement we migrate group towards the nitrogen. Okay, here you can see, and then carbocation is formed. That carbocation get attacked by water, and further reaction takes place to give us amide. Okay, let us continue towards the next example. So try to solve this example by your own. So this example is little bit different. So what is difference here in previous and this example? So you can see here I have taken an unsymmetrical ketone. What is unsymmetrical ketone? Ketone which have different substituents to the carbonyl center. This is carbonyl center, and it have two different substituents. Okay, so how this reaction will take place? I have a hint for you. You have to solve this example by using migratory aptitude. Okay, So let us solve this example. Okay, the first step is formation of oxime. I have formed here oxime, attack of hydroxyramine on carbonyl center, electrons involved in pi bond formation transfer toward the oxygen. Okay, and then after removal of water we get our oxime. So what is next step? What is the next step? Yes, next step, in the next step we will protonate our OH group to convert it into good living group. Okay, so here you can see I have used HCl as HCl is given in our reaction. Okay, you can see here also. Okay, here in example HCl is already given, so I have taken HCl. Instead of HCl sometimes you get another reagent like H2SO4 or any other acid. Okay, so what is the role of that acid? To protonate OH. Okay, let us continue toward our mechanism. I have used HCl which protonate OH. I have mentioned I have shown it with a different color so that you can understand well. This HCl proton from HCl with green color. Okay, then after protonation what will happen? Rearrangement takes place to form a carbocation. Okay, now what is the next step? What will be the next step? Yes, in the next step we will attack our carbocation with water. Okay, yes, you can see here water which attacked to our carbocation and we get our amide. Okay, this is our amide. Okay, and now this example is quite different. What is difference in this mechanism, or sorry, example? The difference is of reagent. I have used PCl5 instead of any acid. Up to now we have used acid. Now we will see how we use any catalyst instead of acid. Okay, so let us see this example. Okay, nothing is much difference in this example. Same, hydroxylamine attack to the carbonyl center, oxygen get negative charge and it will formed our oxime. Okay, after oxime formation what we did in previous examples, we convert OH into the good living group by protonation, but we don't have any source here to protonate OH. Okay, so what we have? We have PCl5. So what is the role of PCl5? To is the same role. We will convert OH into good living group. Just the way is different. The pathway is different. Mechanism is different. So let us see this mechanism. What will happen? The lone pair will attack on the phosphorus. One chlorine will get removed. Here I have mentioned it. Green color. Cl will remove. So what we have? 4 chlorine groups, 1 2 3 and 4 in 4 chlorines. Okay, now what will happen? Again oxygen get positive charge, so for neutralize that it will remove its proton and we will here byproduct is formed HCl in the form of HCl. Okay, as you can see here I have written here Cl minus. So phosphorus will have in 3 chlorines in next step. Here 1 2 3 and pi bond over here. But it doesn't work for oxygen. Okay. Still there is a positive charge. So what he will do? He will leave the nitrogen bond. Okay. So for that it have some driving force, right? So what, from where it get driving force? The rearrangement reaction. The phenyl group over here get migrated towards the nitrogen and this bond will get broken. Here you can see this. Okay, phenyl group migrated towards nitrogen. Here carbocation is formed and oxygen gets oxygen nitrogen bond breaks and it leaves in the form of POCl3. Okay, phosphorus, 1 oxygen and 3 chlorines. Okay, POCl3. And again, as we know that after carbocation formation, we will attack carbocation with water to get our amide. Okay, this is very simple reaction. I hope you understand this reaction. So this is some theory part to for more understanding. You can read this to get more clarification of your doubts. Okay, I hope you understand this reaction. These are some applications of Beckmann rearrangement. Okay, so Beckmann rearrangement is used to formation of polymers like caprolactam, which is used in the synthesis of nylon 6,6. Okay, so here what which here cyclohexanone is used. Cyclohexanone hydroxylamine, which form cyclohexanone oxime. Here they have used sulfuric acid for protonation of OH. Okay, and after protonation, rearrangement will take place and caprolactam will form. Okay, so try to solve mechanism for these examples. Okay, Beckmann rearrangement is also used in the drug synthesis. Okay, so here they have used Beckmann rearrangement in synthesis of paracetamol. How? First of all, acylation of phenol is done. Phenol acylation. Okay, so we have get you can see this. This is a ketone actually, phenol derivative, but it is ketone. How? The carbonyl center have two different groups, unsymmetrical ketone like, is it? Okay, now reaction will take place here. We don't have to think about this. Okay, what we have to do is all about this. Okay, hydroxylamine will form oxime. You can see here oxime, and then oxime, this is nothing but trifluoroacetic acid. Okay, trifluoroacetic acid have, what is the role of acid? Role of acid is protonation. It will protonate OH and this will get converted into amide. Okay, so we get paracetamol. Okay, I hope you all understand and you will solve the all problems by your own. Best of luck and thank you.